Um, the first direct image of a planet while it's actually forming.
No way. A direct image of planet formation happening right now.
Exactly. It's called WISP-bit 2b. And it's a gas giant, a big one, apparently growing inside the disk around its star.
A gas giant, like Jupiter.
Or even bigger, according to the reports. Something like 5 times the mass of Jupiter.
5 times Jupiter's mass. That's enormous.
It really is. And its presence, well, it seems to confirm a long-standing theory.
Okay, which theory is that?
You know how we see those gaps in the dusty disks around young stars?
Yeah. Protoplanetary disks.
Right. The idea has always been that forming planets are like the force clearing out material, creating those gaps.
Ah, so this observation pretty much proves that the planet WISP-2b is the one that made the gap it's sitting in?
Precisely. I mean, seeing it right there actively forming in the gap, it's strong validation for that model.
That is cool. But how? How did they manage to isolate just the planet's signal? Those disks are bright and messy, aren't they?
Yeah, incredibly challenging. They used a very specific technique. They focused on H-alpha light emissions.
H-alpha. That rings a bell. Isn't that connected to hydrogen gas?
You got it. It's basically a spectral signature. It tells us there's hot hydrogen gas there.
Okay. So how does that point to the planet forming?
Because that specific light signature indicates hydrogen gas is actively, falling onto WISP-bit 2b. It's being accreted by the planet.
Ah, so the light itself is evidence of the growth. It's like catching it in the act of eating, basically.
Right, exactly. It confirms the planetary growth is happening right now. It's not just a static object sitting there. It's actively accumulating mass.
Wow. So direct image, confirmation of gap clearing, and proof of active accretion all in one go.
Pretty much, yeah. It's a really significant observation for understanding how planets, especially these big gas giants, come together.
That really is amazing. A big step forward. Our next story takes us to the world of fusion diagnostics. There's a story about a pretty big leap forward.
Yeah, that's right. It involves an AI tool called Diag2Diag, developed by Princeton scientists and international partners.
Diag2Diag.
Yeah.
And it helps with missing plasma data.
Exactly. It fills in those gaps with synthetic information, but it's highly detailed synthetic info.
How synthetic are we talking? Like better than the real thing?
In a way, yes. That's what's so innovative. You feed it data from one type of sensor, and it generates a synthetic version for a completely different sensor. And yeah, some reports say this data can actually be more detailed than a physical sensor could even capture.
Wow. More detailed. That sounds crucial, especially for monitoring the plasma edge, the pedestal.
Absolutely. That area of the pedestal, it's notoriously difficult to measure accurately. So this level of synthetic detail is, well, it's a big deal.
Does that change things for reactor design then? I mean, if the diagnostics are better or synthetic?
It really could. Some experts believe enhancing diagnostics this way means we might rely less on, bulky physical hardware inside the reactor.
Okay. So potentially making future commercial reactors, more compact?
More compact, yeah. And probably more robust, too, according to those sources. Less complex hardware crammed in there.
Interesting. And I also read it helped with some complex theories.
It did, yeah. It provided really detailed data that supported the magnetic island theory.
Okay, the theory about how RMPs work, those resonant magnetic perturbations.
That's the one. How they actually suppress ELM's edge-localized modes. This detailed synthetic data seems to give a clearer picture of that mechanism.
So it's not just filling gaps, it's actually helping validate or refine physics theories, too?
Precisely. It's a powerful tool for both operations and fundamental understanding.
Our final story takes us to the Saudi Arabian desert, where an absolutely incredible find has been made.
Oh, you mean the monumental rock art discovery? Yes, south of Nifud. It's truly amazing stuff.
Truly amazing is right. The dating on it is just, wow. Somewhere between, 11,400 and 12,800 years ago?
Exactly. And that makes it pretty much the oldest dated monumental rock art found anywhere in Arabia. It's a huge deal.
And we're not talking about a few scratches here, right? We're talking dozens of panels.
Dozens. With well over 100 animals carved. And they're life-sized. Huge camels, ibex, and even aurochs, those big wild oxen that went extinct.
Right, aurochs. And what's really fascinating, some reports mention a crucial link to water, like temporary water sources.
Yes, that's a key part. A lot of the carvings apparently show male camels in rut.
In rut? How can they determine that from a carving?
Well, according to the experts, it's the way the neck muscles are shown really straining. And that specific behavior, it ties directly to the rainy season. That's when these desert pools would actually form.
So it clearly shows they really understood the seasons, the environmental cycles.
Precisely. It points to deep seasonal knowledge. And think about the sheer physical effort involved here. This wasn't casual graffiti.
No way. I read some of these engravings were done way up high on cliffs.
Oh, yeah. Some are like 128 feet off the ground. That's serious, dangerous work.
It really suggests how culturally important this must have been to them, perhaps spiritually, too.
Absolutely.
Yeah.
That level of dedication is highly significant. And some experts in the field think it really changes the historical narrative.
How so?
Well, it suggests these communities were maybe more settled, more established in these desert environments, much earlier than we previously thought.
So they weren't just passing through, they truly mastered the landscape.
Exactly. They knew it
Yeah.
incredibly well. It shows a sophisticated adaptation to a pretty harsh place long, long ago.
Incredible discovery. Really shifts perspective. That's it.